today.
Thank you, Mallory. I would like to thank the organizers for the opportunity to present in the conference, and all of you for attending the last talk of the day. I know that some of you are in Europe and it must be getting late, and even for those of us in the United States, the afternoons may not be very productive. So the title of the talk is Affirmative Action with Overlapping Reserves, and it is a joint work with Tayfun Sönmez. So like Brent, so this paper is going to be about affirmative action, but unlike his talk, we're not going to have any sophisticated structural models. We're not going to have any earnings or college quality. We're going to be in a much simpler world when there's only one institution who's trying to decide which set of applicants to give some positions to. All right. So I guess I have to give you a couple of sentences about affirmative action. So these are policies to promote underrepresented groups in the society. You may want to promote them in allocating public school seats, government jobs, and legislative positions. And these policies can be found throughout the world. And so what we are going to study is directly applicable to for some of the markets in these countries. I may be able to talk about a couple of markets from Chile and India if time allows, or I'll just mention along the way as I present the paper. So the model is really simple. We're going to have only one institution, which is going to decide which set of applicants, which set of individuals are going to get the identical positions that they have. So here we have positions to allocate, and these positions are all the same. They are homogeneous. Therefore, what we do is the design and analysis of choice rules. Right? So a choice rule is going to take a set of individuals who are interested in the position and is going to choose a subset of the set of individuals. These choice rules are going to be based on a couple of things. First, it is going to be based on a priority ranking of individuals. Think of this as merit scores, as in India. So these merit scores rank all of the individuals strictly. And it also depends on a number of reserved positions for each target group of individuals. Think about disabled people, think about veterans. They may have a number of seats reserved for them. The key feature of our model is that an individual can belong to more than one group, right? So we call this the overlapping reserves case. For example, you can be a disabled individual and you can also be a veteran, and there can be positions reserved for disabled individuals and also for veterans. In today's talk, I'm going to focus on the following accounting convention that when an individual is chosen, then they are going to accommodate only one reserved position, right? So if I'm a disabled veteran and I get a position, then I may be able to get a position reserved for veterans, or I may be able to get a position reserved for disabled individuals. There is an alternative accounting convention that we call many to all. So when you're admitted, you count both as a veteran and also as a disabled individual. I'm not going to have time to discuss that in this talk. That one is a little bit more complicated because it creates complementarities among individuals. And but we do analyze that in a working paper version of this paper. So I forgot to full screen the slides. Okay, so hopefully this is better. All right, can you guys still see the slides? All right. So let me now talk about the properties and the properties that we're interested in and the main results. So we're going to impose three. So sorry, I can't see you. So let's go back. All right, so this is better because I couldn't see you. Now I can. Okay. So there are three main properties. The first one is called maximally accommodating reservations. So basically, you want to fill as many of the reserved positions as possible. The second one is called elimination of justified envy. It is really simple. Let's suppose that there are two individuals. One individual who is chosen and one individual who is rejected. If the rejected individual has a higher score than the chosen individual, then it must be the case that the individual who is chosen with a lower merit score must be chosen because of the affirmative action policies. And finally, we're going to assume non-wastefulness. If there's an empty seat, it must be the case that you've chosen all of the students. Our main result states that the choice rule that we introduce, the meritorious horizontal choice rule, is the unique choice rule satisfying these three conditions. It is meritorious because if you compare the set of chosen individuals to any set of individuals chosen by another choice rule satisfying maximal accommodation of reservations, this choice rule is going to choose individuals with higher merit scores, and it's horizontal because we use it to implement the horizontal reservations in India. So I'm not going to have too much time to discuss the related literature, just only maybe a few papers that are directly related to what we do in this talk. So minimum guarantee reservations are studied in the literature by a series of papers by Echenike, Ehler, Safaler, Yildirim, and myself. So these papers assume that the reservations are not overlapping, so each individual has at most one trait. The overlapping reserves is studied by a recent paper by Kurata et al. But so they solve this problem by assuming that individuals rank positions reserved for different traits, and they apply for these positions. So they introduce some artificial tie breaking among the positions for which individuals may be indifferent. So we show in our paper that this way of breaking the indifferences introduces some difficulties. For example, you may not be able to fill as many positions as possible for which you have reserved. You may not be able to fill as many as reserved positions as possible, and two, even if you do, you may be admitting individuals with lower merit scores. So one application is from Chile and Korea et al. Talk about the Chilean market and how they designed a reserve system there. They use this. They use the system of Kurata et al. And as a result, we believe that if our choice rule is implemented in the context of Chile, it may improve the outcome. And finally, so this paper is accommodated. We integrated the results of this talk in our paper where we study affirmative action policies in India. Let me now talk about the model. So there is going to be some number of identical positions. That number is denoted by Q. There's going to be a set of individuals who are interested in getting a position. This is denoted by calligraphic I. Each individual may have a set of traits, like think about having a disability, being a woman, a minority, veteran. So the set of traits is denoted by calligraphic T. The set of traits for individual I is going to be denoted by tau of I. So if you're a disabled minority, then tau I is equal to disabled minority. There is a merit ranking of individuals. So there's a priority order of individuals. This is denoted by pi. And I, pi j, will mean that I has a higher priority than j. For each trait T, a number of positions is reserved. That number is denoted by RT. And the sum of the reserved C's obviously cannot be more than the total number of positions Q. Right, so we would like to write down a really simple model that reflects our applications. And hopefully you'll agree with me at the end of the talk that this is a good model of the applications. So in order to study this model, we introduce a reservation graph. So a reservation graph is going to be two-sided. On one side, we're going to have positions reserved for each trait. So if there are 3 traits and you have one position for each trait, you're going to have 3 positions on one side. And on the other side, you're going to have individuals. And we're going to connect individuals with positions if the individual has the corresponding trait of the position. I'm going to work with the following example throughout the talk, and you don't have to remember everything. It's simple. So there are 7 individuals, I1 through I7. There are 3 traits only, T1, T2, T3. For each trait, we have only 1 position reserved, and there are 5 positions in total. We number the individuals so that I1 has the highest merit score and I7 has the lowest merit score. And the traits of individuals are given by this function tau. You don't have to remember that. I will show you the reservation graph in the next slide, which will show you who has which trait. So here, so this is a reservation graph for our example. So I1 is not connected to any of those. So we have individuals on one side on top, and we have reserved positions. S1 is the position for trait 1, S2 is the position for trait 2, and S3 is the position for trait 3. I1 does not have any trait. As a result, I1 is not connected to any of these positions. I2, on the other hand, has all of the traits. Therefore, I2 is connected to all of the positions. And if you look at I4, I4 has only trait 1. Therefore, I4 is only connected to position for trait 1. Now, in order to introduce the properties that we're interested in, I will have to use the following. So we count the number for any set of individuals I, we calculate the number of reserved positions that can be filled in the reservation graph for I. That number is going to be n over I. Okay. So for example, let's go back. So here, so if you look at n of I1, it is going to be 0 because you cannot match any reserved position. If you look at n I2, I4, this is going to be 2 because you can match I2 with the position reserved for trait 1, and you can match I4 with the position reserved for trait 2, S2. Okay. Just a little bit of notation. And we need the following. An individual I is going to increase reserve utilization of set I if the number of reserved positions that can be filled in I union individual I is 1 more than the number of reserved positions that can be filled by set I, right? So in the previous example, so let's go back again. So I have a different example in the slide, so let's use that. So n I1, I2 is 1, right? Only 1 reserved position can be filled by individuals 1 and 2. If you look at, if you add I4 to the set, now you can fill 2 positions, right? So I2 can be matched with the first position, I4 can be matched with the second position. Therefore, I4 increases reserve utilization of the set, including I1 and I2. So that's the terminology that we're going to use. So our solution concept is a choice rule. All of the positions are the same, homogeneous goods, homogeneous positions. Therefore, what we study is a choice rule. A choice rule is going to be a function C, and given any set of individuals I, it is going to return a subset of the set of I, and it is going to choose at most Q individuals because there are Q positions. What are the properties that we want? First one is maximal accommodation of reservations for any given set of individuals I. If you look at the number of reserved positions that can be filled by the individuals chosen, they should be greater than any subset of I. So you're maximally accommodating reservations. You're choosing a subset such that you're able to fill the maximum number of reservations for the set of applicants, for the set of individuals who are applying for this job. Okay. The second one is called no justified envy. If an individual I is chosen from a set I and J is rejected. So let's look at this. So this is the chosen set. And I is chosen, so I is in the set and J is outside. Now let's suppose that J has a higher merit score than I. To have no justified envy, it must be the case that the number of reserved positions that can be filled by removing I and adding J, okay, goes down by 1 compared to the number of reserved positions that can be filled by the set of individuals chosen, which is CI, right? If a lower merit score individual is chosen rather than a higher merit score individual who is rejected, it must be because of the affirmative action policies. And finally, we assume non-wastefulness, which will mean that if there's an empty seat, it must be the case that all individuals are chosen. So we're going to choose individuals as long as we have empty seats, empty positions. So these three properties are really important. And I'm happy to take any questions on these properties. If you can send me in the chat, or you can raise your hand if you want. All right. Okay, so let's just continue. So we introduced the following choice rule. As I told you in the introduction, we call it the meritorious horizontal choice rule. So in the draft, which is available on the conference webpage, we call it envelope choice rule. So we change the name now, we call it the meritorious horizontal choice rule. We also change the notation, we denote it by CM, and it works as follows. So there are two main steps, step 1 and step 2. Step 1 has some sub-steps, okay? And step 1 is really the main step of the algorithm. So at the first step, you choose the highest merit score individual who has a trait for which there is a reserved position, okay? And any sub-step 1K, you consider the highest merit score individual who increases the reserve utilization of the set of chosen individuals thus far, okay? And you continue doing this until you cannot find such an individual any longer. And then we move to step 2. At that step, we just fill the empty seat, so you cannot increase the reserve utilization anymore. You just fill the empty seats, you just fill the empty positions with the remaining individuals according to their merit scores. Now, this is a long description. Let me show you how it works with the example that I introduced earlier. At step 1.1, we choose the individual who has the highest merit score for which there is a reserved position. We cannot choose I1 because I1 does not have any trait, but we can choose I2 because I2 has all of the traits, and for every trait, there is a reserved position. So at this point, we're flexible about which position I2 is gonna take. It could be for trait 1, trait 2, or trait 3, right? So that the flexibility is what is novel in our approach, and this flexibility will be crucial in establishing the properties of this choice rule. At the second step, step 1-2, so we cannot choose I3 because I3 does not have any trait. Now we move on to I4. The question is, does I4 increase the reserve utilization of the set I2? Okay. Now, if you consider I2 and I4 together, now I2 can be matched with position 1, I4 can be matched with position 2. So I4 does increase the reserve utilization of the set of students or the set of individuals chosen so far. I4 is also chosen. So this is step 1.2. That's great. Now let's look at the next step, step 1.3. So here we've chosen I2 and I4 so far. The question is, can we add I5 to the set? The answer turns out to be yes, because I5 increases the reserve utilization of I2 and I4, but this increase can be seen by reshuffling the matching of positions to the individuals. Now, if we match I2 with position 1, we won't be able to match I5 with the reserved position, so we don't do that. So we match I5 with position 1, then I4 has to be matched with position 2, and I2 has to be matched with position 3. I5 does increase the reserve utilization of the set of individuals chosen so far, and they are chosen. Since there are 3 individuals and 3 positions, then we cannot increase the reserve utilization. So we stop and then we go to step 2. At step 2, we have 2 empty positions and we have the remaining individuals. So I1 and I3 are chosen for these empty positions. So that's the choice rule. So we hope that it's really simple and it's really easy to understand. And now let's look at our first result. let's take any choice rule that maximally accommodates reservations. So C can be any choice rule that maximally accommodates reservations. Then for every set of individuals I, the following is true. 1, the number of individuals chosen by the meritorious horizontal choice rule is weakly greater than the number of individuals chosen by C. And furthermore, if you rank these individuals, so let's rank all the individuals according to their merit scores in CI and by meritorious horizontal choice rule, right? And let's rank them according to their merit scores. So the first individual chosen, the individual that has the highest merit score chosen by CM, the meritorious horizontal choice rule, has a higher merit score than the highest merit score individual chosen by C, and so on and so forth. So this is why we named the choice rule meritorious. So among all choice rules that maximally accommodate reservations, this choice rule chooses individuals who has the highest merit scores. All right, so, and our second and perhaps main result is the following. Suppose that we impose the 3 conditions that I introduced: maximal accommodation of reservations, if the choice rule also satisfies no justified envy and is non-wasteful, if and only if it is the meritorious horizontal choice rule CM. So these 3 properties uniquely define the meritorious horizontal choice rule CM. Now, so you can ask, and we have a little section in the paper. So what happens if there are multiple institutions that have different positions? So in that case, we think about these institutions having the meritorious horizontal choice rule and using the individual proposing deferred acceptance algorithm of Gale and Shapley, which is one of the main algorithms studied in the market design literature. So does it work well? Can we do that? The answer turns out to be yes, because this meritorious horizontal choice rule, CM, satisfies the properties that are needed for DA to work well. So those properties are called substitutability and the irrelevance of rejected individuals. Those 2 properties are satisfied. As a result, we can accommodate our choice rules in a market with different institutions and different positions. So I may be a little bit early, but I guess everybody will appreciate that, especially those of you from Europe. And the next time you see me, you can get me a beer. So let me conclude. So as I told you in the introduction, there's an alternative approach where a chosen individual will accommodate all of the traits that they have. So we do have an analysis of this in the paper, but it turns out to be more tedious, and it turns out that we can still identify choice rules that satisfy these 3 properties in that context. Right now, it's not going to be a unique choice rule, it's going to be a choice correspondence, because sometimes these axioms will not be able to differentiate between sets of individuals because there will be complementarities. A minority female candidate is going to be complements with a majority male candidate. And those complementarities create difficulties. And it turns out that if you look at that choice correspondence, there is no selection of that choice correspondence that satisfies the substitutes condition. So you won't be able to take that and incorporate that in a bigger market with different institutions. So as I told you earlier, so we've actually incorporated this paper to our another project where we studied Indian affirmative action policies. So this choice rule is equipped really extremely well to accommodate the so-called horizontal reservations in the Indian context. So in India, there are horizontal reservations for women, there are for disabled individuals, for veterans, and it is used throughout India. And the reservations for women are mandated by the federal government. So we apply this. It involves sequential application of the horizontal choice rule based on castes of individuals. So if you're interested about that, I'm happy to talk later in the breakout room, or you can also look at the paper online. And finally, in the paper, we look at the potential improvement in implementing the school inclusion law of Chile, which was passed in 2015. Now, K through 12 assignment in Chile is centralized, and they have reservation policies. And the paper that I told you in the beginning talks about the implementation of these reservation policies in Chile. We believe that there could be improvements to the Chilean implementation by using our meritorious horizontal choice rule. And that's it.